Hi. So we're going to talk about the percent yield. When we went over our last section, we talked about limiting reactants, and we also talked about what the products were if we were given a set amount of reactants. So if we gave ourselves a little bit of something and then a lot of something else, that little bit of something would be a limited reactant. So we are going to go over some definitions of this percent yield. This theoretical yield is going to be the calculated amount of product. So calculated amount of product. The actual yield is what we find in the lab. And this percent yield is going to be the comparison of calculations versus the result. Okay, so what does this all mean? We have a theoretical yield, and this is something that we will be able to theoretically understand based on like a recipe box. This should make 8 cupcakes, and but if we end up making uh, you know the actual yield, if we end up making like 6, well, maybe we didn't do our measurements correctly. We didn't follow that recipe to standard, and the theoretical yield should always be set. So let's take a look at some examples here. So our little equation here, percent yield equals the actual yield divided by the theoretical yield times 100%. That's to get our percentage of what the actual percent yield is. So let's take an example here. A cookie recipe says it should make 32 cookies, and you only make 28. Some of the cookie dough got eaten. Okay, so what was the theoretical yield? Well, theoretically, we should have been able to make 32 cookies. Okay, however, the actual yield that we made, because apparently some of the cookie dough got eaten, so the actual yield was 28. So the overall percentage yield that we were able to acquire here was 28. So that's going to be our actual yield divided by our theoretical yield of 32. We're going to multiply that times 100. So this is going to be 0.875 times 100, and that would be 87.5%. So we'll have 87.5%. Anytime, so if we had this equivalent to, and percentages are pretty nice to handle here. So if we had 0.875 and we times it by 100, all we need to do is move this 2 decimal places because there's 2 zeros in that 100. So it's really easy to do these percentage changes or multiplications, or just multiplying by tens, hundreds, thousands, etc. Moving forward, a container of frosting says it should frost 24 cupcakes, and you are able to frost 28 cupcakes. What is the theoretical yield? Well, technically, we should be able to withhold 24, or rather, we're able to frost 24 cupcakes. We actually were able to frost 28. So what was the percent yield? Well, we need to do the math on that. That's 28 divided by 24 times 100%. We end up getting 116% with that. Okay. We should never get 116%. We should never get anything over 100%. Okay. So if we get something that's over 100%, there's clearly some sort of human error that occurred there. Maybe we added too much water, and so you're able to frost more cupcakes, but really you just wetted down more cupcakes, or whatever you want to explain. I mean, there could be a enumeration of things. Something might have fell into the frosting, some extra powder or whatever, and now you have more frosting. So is it actually frosting? Maybe you got lucky and more sugar landed in it and enough to be able to frost more. I don't know. So you want to be able to understand what the human error is if you find that your percent yield is more. And that's why it's okay to claim your mistakes in science. So no sweat if you do, just make sure you figure out why. Moving forward here, we're going to utilize the following reaction of 2Na or sodium plus chlorine gas, Cl2, and that's going to produce 2 moles of sodium chloride or salt. A reaction occurs with 45 grams of chlorine gas and an excess of sodium. Calculate the theoretical yield. Okay, so we have what we were given, this 45 grams. So we start off our stoichiometry with that. We want to convert this into moles, as we can see here. And so if we looked at the periodic table, I believe chlorine is 35.45 grams. We multiply that by 2 and we get 70.9. Okay. And when we look at our equation here, we have 2 moles of NaCl and 2 moles of sodium and 1 mole of chlorine. So 2 moles of NaCl, 1 mole of chlorine gas. Moving forward here, 1 mole of sodium chloride, that's going to be 58.4. And I had to use a cheat sheet for that to be exact. I think it was sodium's 22.99 plus 35.45. And I'm already lost on how to add that together. So anyway, 58.44. We need to multiply all of this together. So if I used my calculator here, I am simply going to type in 45 times 2 times 58.44 equals divided by 70.9. And I get 74.18 grams of sodium chloride. Okay. When the reaction happened in the lab, it actually produced 71.23 grams of sodium chloride. What is the percent yield for this reaction? So the theoretical yield is 74. So we have theory over actual, if you want to remember, times 100%. Okay, so in theory, we should get 74.18. So we're going to toss that on the bottom. Or actually, I think I got this incorrect. I think we need to flip-flop that. It's going to be actual over theory. Let's see if my theory is correct here. So if we go up and look at what we wrote down, actual over theoretical. Yep. Actual over theoretical. So let me go ahead and erase that. It's always fun. Every time I do something new, or rather do something I haven't done in a while, I find my own mistakes. That's good. And we times this by 100%. Okay. So we have what we actually got. So that's going to be 71.23 grams of NaCl. And our theoretical yield, as we can see up here, is 74.18 grams of NaCl. Okay, so we are going to times that by 100%. Whoa, 100%. And I need my calculator for that. So if we take 71.23 divided by 74.18 times 100, I get 96. 96%. And that is our percent yield, is 96%. I hope we learned something today. Thank you for joining me, and I hope you have a good day.